Okay, hello class. So let's work a problem. This is one of our homework problems. Just kind of want to work the solution out so one can see it, kind of get comfortable with calculating support reactions and drawing free body diagrams. So as far as our solution is concerned, we're asked to determine the force in each member of this particular truss. And we got to state if the member is in tension or compression. So our first step really is to draw a free body diagram. Okay, so this is a roller and this is a pin. So a roller only has one restriction, okay, and a pin has two restrictions, okay. So I have them outlined the way they are. Um, Again, if you kind of feel the problem, you'll kind of know how the support reactions will orientate themselves. Again, this is a static problem, so this structure should not be moving at all. It should be in equilibrium, okay. Um, so let's take it a step further. After we've drawn our free body diagram, I want to calculate our support reactions. So in doing so, in step number 2, you're typically using like 3 equilibrium equations. Okay? And one of them is sum of the moments about any point. And I'm always taking clockwise to be positive. And then sum of the forces in the y direction equals 0. And then sum of the forces in the x direction equals 0. I'm taking that direction to be positive. Okay, so these are your 3 equilibrium equations that we typically use. So what I'm going to do now, I'm going to take the moment about point C. Okay, we'll take the moment about point C. So the sum of my moments about point C equals 0, and I'm taking my direction to be clockwise. Okay, so this is my point of interest right here. So I'm going to have my 450 pounds, comes in contact with this directional arm of 4 feet, and it's going to make it's going to create a moment in the negative direction. Okay, and I'm going to go with my AY. The next force is AY, and AY is 8 feet away from point C, and that's going to give me an expression like this, and that's going to equal 0. Okay, so I can typically solve for my AY, and that gives me 225 pounds. Okay, now I can take the moment about point A. I'm going to take it clockwise to be positive. Okay, and when I do so, so now this is my point of interest right here. Okay, and that gives me an expression whereby my CY is pointing down, and when it comes in contact with the distant arm, that's of 8 feet, it's going to give me a positive CY of 8 feet. Okay, and then my 450 from point A, it's actually going to go in the opposite direction. Okay, that's 8 feet. That's 4 feet. Sorry. Okay, because now this is my 450 pounds, and it's 4 feet away from my point A. Okay, this is my point A going across this way, and I'm 4 feet away, and this is a force of 450 pounds. When it comes in contact, when this 4 feet comes in contact with this 450 pounds, it wants to rotate that 450 pounds that way, counterclockwise, which will be negative in our sense, because I've already told you in the beginning that I'm taking clockwise to be positive. Okay, so when I do that, set this equal to 0. If I solve for, here I'm going to solve for my CY. So my CY equals 225 pounds. Okay, so I'm going to use another equilibrium equation. I'm going to use some of the forces in the x direction equals 0. taking that to be positive, from left to right to be positive. And in doing so, when I look at my free body diagram here, right, let me just clean some of this up if I can. Okay, let's clean this up a little bit so we can see. Okay, so when I look at my free body diagram, what kind of forces do I see in X direction? Well, I see my CX here, and I see this 450 pound here. So that being said, I can now move forward and say some of the force in X direction will be a positive CX minus 450 pounds equals 0. When I solve for CX, CX equals a positive 450 pounds. Okay. Okay, now that I've done that, I want to now calculate my my third step, step 3. I want to look at the individual joints. Okay, so I'm just going to copy this real quick here and bring this down with me so we can see it. Copy. I'm going to paste it here. Okay, and I'm going to start off with joint A. Okay, so this is my joint A here. I have AY, and in this case, you're always just drawing, you're keeping your members in tension. So this is going to be force AB. Okay, and this is going to be my force AD. Now, since you and I know that this length is 4, this length is 4, so this is an isosceles triangle. Therefore, force AD can be broken up into two components, FAD cosine 45 degrees and FAD sine 45 degrees. Okay, so with that being said, now I can still use my equilibrium equations. I'm going to use some of the forces in the, let me just bring this up a little bit. Okay, and I'm going to take care of this. I'm going to say some of the forces in the X direction. Well, I want to use Y. I'm going to use Y direction equals 0. My AY was 225. So some of the force in the X direction will give me AY plus FAD sine 45 degrees. Okay, equals 0. My AY is 225 pounds. I want to find FAD, right? That's what I want, right? So I'm going to do this then. I'm going to solve for FAD. And when I do so, FAD equals negative AY over the sine of 45 degrees. It's negative 225 pounds. Divide that by sine 45 degrees. My FAD equals 318.2 pounds. And it's going to be a negative, so it's going to be in compression. Okay. Okay. That's my answer for that. Now I want to take it a step further and say some of the forces in the X direction equals 0. And I'm going to now look at my structure here and say, okay, what forces on the X direction? Well, I see FAB plus FAD cosine 45 degrees. Set that equal to 0. Those are only two forces in the x direction. Okay. Now, if I take it a step further, I want to solve for FAB. I already know what FAD is from here. So if I do that, I'm going to get FAB equals negative FAD cosine 45 degrees. Okay, so my FAB equals negative 318.2 times the cosine 45 degrees. FAB equals a positive 225 pounds, and that's going to be in tension. Okay, that's our answer here. Okay, so we're done pretty much with this joint. Now let's move on to the next joint. I'm just going to paste this here. Okay, let's move on to joint C. Okay, when I look at joint C, I have a few forces acting on it. I have this force right here, CX. I have CY. I have FCD. Okay, and I have FBC. Okay, and the CD, I have a force FCD sine 45 degrees, FCD cosine 45 degrees. Again, because this is going to be 4, this is going to be 4. It's an isosceles triangle in terms of their length. Okay, so in doing so, now I can say some of the forces in the y direction equals 0, and that's going to be all the forces in the y direction. I'm going to get a negative cy right from here, a plus FCD sine 45 degrees equals 0. Well, I know what cy is from my support reaction, right? cy was 225 degrees. 225 pounds. So if I solve for FCD, it's going to give me positive cy over sine 45 degrees. And that's going to give me 318.2 pounds. And that's going to be in tension. Okay? Equals FCD. Okay. Now, I'm going to do some of the forces in the x direction equals 0. Okay. And when I do that, I'm going to look at all the forces in the x direction. And that's going to be negative FBC plus CX, and then my minus FCD cosine 45 degrees equals 0. And when I do the math, I'm going to get FBC equals a positive 225 pounds, and that's going to be in tension. Okay. I hope this helps. Thank you very much. If you have any questions, please let me know. Thank you. Bye-bye.